For most people, that sounded like the end of the story. One final NASA headline, one historic moment, and then silence. But in 2026, NASA is still fighting to keep it alive. Why? Because Voyager 2 is now beyond the sun's protective bubble, sending back data from a place no human-made machine had ever explored this way before. Its power is dying, its instruments are being shut down one by one, and every message takes almost a full day to reach it. If one system fails, NASA may lose it forever. So the real question is not how far Voyager 2 has gone. The real question is, what is it still finding out there? Here is what actually happened and why it still matters more today than it did the moment it occurred. On November 5th, 2018, Voyager 2 slipped across an invisible boundary called the heliopause, the outer skin of the bubble of solar, wind, and magnetic fields that the sun projects around our entire solar system. At that moment, the probe was 119, 7 astronomical units from the sun, moving at roughly 15, 3 kilometers per second, and it became only the second human-made object in history to leave that bubble behind. The first was its twin, Voyager 1, which had made the same crossing 6 years earlier. 2 machines, launched in the same year, built from the same blueprints, independently confirming that the boundary of our solar system is real, physical, and measurable. Not a theory, not a model, but a wall of plasma that a piece of 1970s engineering physically punched through. But here is where it gets uncomfortable. That crossing did not happen with fireworks or a countdown clock. It happened quietly, detected only because onboard instruments picked up a sudden, unmistakable jump in the density of plasma around the spacecraft, the fingerprint of interstellar space replacing the fingerprint of our sun's influence. Think about what that means. Humanity did not watch its own boundary being crossed. We only found out after the fact, buried in data, because the only witnesses were machines 4 decades old flying blind, with no camera pointed outward to capture the moment for us. The most significant boundary crossing in the history of our species was invisible to the species that built the ship that crossed it. And this is where the story most people never hear actually begins. Voyager 2 did not stop moving once it crossed. It kept going deeper, faster, farther, and it has not stopped since. As of early 2026, Voyager 2 sits roughly 143 astronomical units from the Sun, about 21, 4 billion kilometers, or 3 billion miles from Earth. Its twin, Voyager 1, is even further out, having pulled ahead despite launching after Voyager 2, because its trajectory sent it on a faster, more direct path out of the solar system. Read that again. One spacecraft launched second and ended up in front. That is not an accident of physics. It is the result of a mission design so precise that engineers in the 1970s were plotting gravitational slingshots around Jupiter and Saturn that would still be playing out, exactly as calculated half a century later. But distance like that is not just a number. It is a communications nightmare that most people watching this story never think about. At 143 astronomical units, light itself, the fastest thing in the universe, takes close to 20 hours to travel from Voyager 2 to Earth. A command sent from Mission Control does not arrive instantly. It travels for the better part of a day, and then, if everything works, a response takes almost another full day to come back. That means every single decision NASA makes about this spacecraft is a decision made 2 days in advance of knowing whether it worked. There is no live troubleshooting. There is no real-time correction. Every instruction is a message in a bottle thrown across a gulf so vast that by the time you know whether it landed, the moment it was meant for has already passed. This is not some hypothetical risk. It already happened, and it nearly ended the mission entirely. In July 2023, a routine command sequence caused Voyager 2's antenna to tilt just 2 degrees away from Earth, a fraction of a degree in the grand scheme of the sky, but enough to sever contact completely. For days, NASA's Deep Space Network listened to silence from a machine that had survived Jupiter, Saturn, Uranus, Neptune, and the crossing into interstellar space and heard nothing back. Engineers had one option left: a maximum power transmission from a giant dish in Canberra, Australia, essentially screaming across the solar system in the hope that a 46-year-old receiver over 11 billion miles away was still capable of hearing a whisper of a command and correcting itself. It worked. But here's what most coverage of that moment left out. The fix relied partly on a backup system built into the spacecraft that was designed to reorient itself automatically if contact was lost for too long. In other words, the machine still remembered how to save itself. The real story is that Voyager 2 came back from the dead using a survival instinct engineered into it decades before anyone alive today could have predicted it would ever be needed. Now think about the deeper problem sitting underneath all of this, the one that no single dramatic incident can fix, because it cannot be repaired, patched, or rebooted. Voyager 2 is dying, slowly by design, in a way that was written into its physics the day it launched. The spacecraft is powered by 3 radioisotope thermoelectric generators, devices that convert the heat of decaying plutonium into electricity. At launch in 1977, those generators produced 470 watts of power combined, enough to run a small household appliance. But radioactive decay does not pause for anyone's mission timeline. Every single year, without exception, both Voyager spacecraft lose about 4 watts of power, permanently, with no way to replace it. There is no refueling station 11 billion miles from Earth. There is no swapping the battery. What launched with nearly 500 watts of power is now surviving on a fraction of that, and the fraction gets smaller every single year, whether anyone is watching or not. This is where the story stops being a science headline and starts becoming something closer to a hostage negotiation with physics itself. Because when your power source is dying and cannot be replaced, you only have one lever left to pull. You start turning things off. And that is exactly what NASA has been doing, instrument by instrument, in a sequence that reads less like a mission log and more like a slow, deliberate act of triage on a patient nobody can reach. In October 2024, engineers shut down Voyager 2's plasma science instrument, the tool that measured the flow of charged particles around the spacecraft. It was not an easy call, but the instrument had been returning limited data anyway due to its orientation, so it became the first sacrifice in a war of attrition against entropy itself. But that was only the opening move. In March 2025, NASA shut down Voyager 2's low-energy charged particle instrument, a device that had been running continuously since before most of the people reading this were born, one that had survived over 5 million mechanical steps on a rotating platform originally built to last through a single flyby of Saturn in 1980. Think about that number for a moment. A motor designed to survive one planetary encounter ended up operating for 45 years and completing more than 8.5 million cycles before engineers finally chose to switch it off. Not because it broke, but because keeping it running was no longer a cost the spacecraft could afford. It did not fail. It was retired mid-sentence because the lights had to stay on somewhere else. And here is where it gets worse, because this is not a one-time event. It is a schedule. Voyager 2's cosmic ray subsystem is next, scheduled for shutdown in 2026, the same year you are watching this. By the time that instrument goes dark, both Voyager spacecraft will be down to just 2 operating instruments each, out of the original 10 each carried at launch. Engineers hope, and that word matters because it is not a promise, it is a hope, that each spacecraft can carry at least one working instrument into the 2030s. That is the honest state of the mission right now. Not Voyager, crossed the edge of the solar system, past tense, mission accomplished. But Voyager is currently being kept alive one amputation at a time, and the surgeons performing that operation are working with a 2-day delay between every decision and every result. This is not chaos, this is strategy. Every shutdown has been chosen, sequenced, and timed by a team of engineers fighting a war against a clock that only moves in one direction. And in 2026, that strategy escalated into something far riskier than simply turning instruments off one by one. NASA is preparing what engineers have nicknamed the Big Bang maneuver, a plan to swap out multiple onboard systems simultaneously for lower power alternatives, rather than continuing the slower, incremental shutdowns that have defined the mission for years. Read that name again. Not a small adjustment, not a minor tweak. A big bang, a single coordinated high-risk intervention performed on a machine that is 11 billion miles away, using commands that take a day to arrive and a day to confirm, on hardware that has not been touched by human hands since the Ford administration. If it goes wrong, there is no do-over, there's no repair crew, there's only the silence of deep space and a signal that either keeps coming or doesn't. What most people are not seeing is why NASA is willing to take that risk at all. The answer is almost poetic in how simple it is. The data being sent back right now is more valuable than it has ever been in the mission's history, precisely because nothing else in the human arsenal can collect it. As one project scientist put it, the science data the Voyager's return only becomes more valuable the farther they travel from the sun, because there is nothing else out there to compare it to. These 2 machines are not just exploring space. They are the only 2 sensors humanity has ever had inside the interstellar medium, the region between stars, and every additional year they survive is a year of irreplaceable data that no telescope, no probe, and no future mission currently on the drawing board can replicate. Because nothing else is out there and nothing else will be for a very long time. And this is where the story takes a turn nobody saw coming, because the past has just reached back and rewritten itself. In early 2026, scientists at the Southwest Research Institute published new research resolving a mystery that had haunted planetary science for nearly 40 years. A mystery created by Voyager 2 itself back in 1986 during its flyby of Uranus. When Voyager 2 passed Uranus, its instruments recorded radiation levels around the planet so extreme that they baffled scientists for decades, with no clear explanation for why the readings were so far outside expectations. For almost 40 years, that anomaly sat there, unexplained. a strange asterisk in the data nobody could fully account for. Then, in 2026, researchers comparing decades of Earth-based radiation belt observations to that old 1986 dataset found the answer. Voyager 2 likely flew through Uranus during a rare solar wind event, a disturbance capable of flooding a planet's radiation belts with a surge of extra energy, similar to storms already observed near Earth. Think about what that means. Data collected 40 years ago by a spacecraft that has since crossed into interstellar space and is now dying of old age 11 billion miles from home just rewrote a chapter of planetary science in 2026, because we finally had the tools to understand what it had been telling us all along. That single discovery should terrify and excite you at the same time, because it exposes something most people never consider. Voyager's most important contributions might not even be behind us yet. Every byte of data it ever collected, going back to Jupiter in 1979, is still sitting in archives, waiting for the right future scientist, the right future instrument, or the right future insight to unlock what it actually means. The spacecraft that is currently losing power, currently shedding instruments, currently surviving on borrowed backup systems and last resort maneuvers, has already proven that its legacy does not end when its transmitter finally goes dark. It ends decades later in a lab on Earth when someone finally understands what it saw. But let's not soften what is coming, because the clock has not stopped and it is not going to. NASA's own project manager has said she would love to see the spacecraft reach 200 astronomical units from Earth, a milestone that, at current speed, would not arrive until around 2035. That is the dream. 9 more years of survival on a power budget that shrinks every single year, using instruments that are being switched off one by one, communicated with through a 2-day round-trip delay, guided by a team of engineers who openly admit that unforeseen circumstances could arise that upend even these already fragile plans. Every year between now and then is not guaranteed. It is a bet that the remaining hardware holds, that the Big Bang maneuver succeeds, that no antenna tilts 2 degrees at the wrong moment, that no random cosmic event finishes what 49 years of deep space radiation has been slowly doing to aging circuitry the whole time. And here is the part that should sit with you long after this ends. Even when the last instrument goes silent, even when Voyager 2 finally stops talking to us entirely, it does not stop moving. It does not come home. It does not slow down. It keeps traveling forever, carrying a golden record etched with the sounds of Earth, the voices of a species that does not exist yet in any recognizable form by the time that record might ever be found, if it ever is. The same mission that gave us the pale blue dot photograph, Carl Sagan's haunting reminder that Earth is nothing more than a tiny, fragile speck suspended in a sunbeam, is now hurtling into a silence with no return address. The machine that once looked back at us on its way out of the solar system has already begun the process of losing its own voice. Soon it will see nothing, hear nothing, say nothing, and simply continue, alone, into a darkness with no edges, carrying humanity's message to an audience that may never exist and may never receive it. So, when you hear that Voyager 2 crossed the edge of the solar system, don't think of it as an ending. Think of it as a signal still fading in the dark. Right now, in 2026, that spacecraft is still moving farther from Earth every second. Its power is dying, its instruments are being protected one by one, and NASA is not just keeping an old machine alive. It is trying to preserve the only voice we have from that far beyond the sun's reach. Because once Voyager 2 goes silent, we cannot send another spacecraft there tomorrow. We cannot replace that data. We cannot rewind the mission and ask the questions we forgot to ask. The most frightening part is not that Voyager 2 will stop one day. The frightening part is that it may stop before we fully understand what it was trying to tell us. And somewhere beyond the edge of our solar system, in a place where the sun is no longer in control, Voyager 2 is still listening, still moving, and still waiting for one more command from home. But no one knows how many heartbeats it has left.